Hello engineers, welcome back. In this video, we're going to talk about an important algorithm called Kruskal algorithm, which is used to finding out the minimum spanning tree in a graph. Okay, I hope you're ready. Let's get started. So, so let's say we have this graph, and as you can see, there are 6 nodes or vertices, and then the edges are now weighted. There is some weight attached to the edges. Okay, so minimum spanning tree says that from the given graph, extract out such a graph that it covers all vertices are covered, and there are exactly v minus 1 edges. Okay, so extract out such a graph that it has all the vertices and v minus 1 edges, and the weights should be minimum. If we take the sum of the weights from that graph, it should have the minimum total weight. So if we have all these properties, then we have successfully created a minimum spanning tree. Okay, and why is it called a tree? If so, you will observe that when we build the graph, it will not have any cycles. So for example, if we look at this one, there is a cycle clearly visible, right? And that final graph will not have a cycle. That is another condition for minimum spanning tree, right? There should not be any cycles. So if we have such a condition, then we have achieved our minimum spanning tree. So how can we build this? So let's look at it from our algorithm perspective. Okay, so in the previous videos we learned about disjoint sets, right? So we have seen how to represent a graph using an array called parent and size, and how we have used path compression, find and union, and methods like that to create such a graph. So we will use the same concept here. Okay, so if this is my graph, so we have these edges here, and the first step in the Kruskal algorithm is to sort them in ascending order. As you can see here, I have sorted them based on their ascending order. So the first edge is Sam Tom with a weight of 2, and then we have Harry and Lucy with a weight of 3, and then we have Ben and Lucy with a weight of 4, and so on. So this is the ascending order. So the first step is to sort them in ascending order. Once we sort them, we process them one at a time using our disjoint set algorithm, right? We will create the parent and size arrays using our disjoint set sequence of steps, right? So as we go along building this, our goal is to build a minimum spanning tree, right? Our goal is to build a minimum spanning tree. So the condition to include one edge into the minimum spanning tree is that it should have no cycle. It should not form a cycle. Okay. If it is forming a cycle, we will discard it. Otherwise, we will include it. Okay. So let's see how that goes. Like, let's start with the first edge, Sam and Tom. Okay. So we know the sequence by now. We will first do find, and if they are different parents, we will do the union. So who is the parent of Sam? 0. Who is the parent of Tom? 1. They are different parents, so we perform a union. Union by size. We check what is the size of set Sam and Tom. They are equal size, so anybody can become the parent of anybody. So let's make Sam the parent of Tom. So Sam is now the parent of Tom, and Sam's size is increased to 2. Okay, and because this is not forming any cycle, we can include it in our minimum spanning tree. I will show you how it looks like when it forms a cycle, right? So because this is not forming any cycle, we will include it in our tree. So this is our spanning tree. We have Sam, Tom with an edge of 2. So this is now part of our minimum spanning tree. Okay, next, let's do the same process for the rest of them. We have Harry and Lucy. Who is the parent of Harry? 3. Who is the parent of Lucy? 5. Different parents. So we perform union. Let's see, union by size. Harry's size is 1, Lucy's size is 1, same size. So anybody can become parent. So let's make Harry the parent of Lucy. So Lucy will now have Harry as a parent, and Harry's size is now increased to 2. Okay, and this edge can now be part of minimum spanning tree. Harry, Lucy, 3. Finished. Now let's go to the next edge. Ben and Lucy 4. Who is the parent of Ben? 4. Who is the parent of Lucy? 3, which is Harry. Okay, they are different parents, so we perform union. So union by size. So what is the size of Ben? 1. What is the size of Harry? 2. So Harry is bigger, so Ben will go to Harry. So Ben will now have a new parent called Harry, and Harry's size is now increased to 3. And this edge can also be part of our minimum spanning tree. So we have Ben, Lucy, 4. Done. Next we have Harry and Jerry. Who is the parent of Harry itself? Who is the parent of Jerry itself? So different parents. So we can perform union. Union by size. So Harry and Jerry. Harry is bigger, so Jerry goes to Harry. So Jerry will now be having a new parent called Harry. And Harry's size is now 4. Okay, this is done. And this can also be part of our minimum spanning tree. Harry, Jerry, 5. Done. Next, Ben and Jerry, 6. So who is the parent of Ben? Harry. Who is the parent of Jerry? Also Harry. So they have the same parent, which means that if we include this into our spanning tree, it will form a cycle. Okay, that's why we will discard it. So how do I know it forms a cycle? Let's see. So what are the edges we have covered so far? We have covered Sam, Tom 2. This is done. Harry and Lucy. This one. This is done. Ben and Lucy. This is done. Harry and Jerry. This is also done. Now if I include Ben and Jerry, this will form a cycle, right? So we will not include this. We will discard this one. Okay. So that is the main piece of the algorithm. So if we find an edge, both vertices having the same parent, then it will form a cycle. So we will discard it. We will not use it in the final output. Okay. Let's see. What is the next edge? Sam and Jerry. Who is the parent of Sam? 0. Who is the parent of Jerry? Harry. Different parent. So we perform union. Union by size. Who is bigger, Sam or Harry? Harry is bigger. So Sam will go to Harry. Okay. So Sam will now have new parent called Harry. And what is the size of Sam? 2. So 2 more edges, 2 more vertices will be added to Harry. So Harry's size will now be 6. And this edge can be part of our spanning tree. Okay, and as you can see, we can safely include this edge without forming a cycle. Now let's see, did we cover everything? Do we have everybody in the final output? Tom, Sam, Jerry, Harry, Ben and Lucy. Sam, Tom, Harry, Lucy, Ben and Jerry. So everybody is included. So the first condition is satisfied. This is done. Do we have v minus 1 edges? So the total number of vertices are 6. So the edges should be 5. So we should have 5 edges. 1, 2, 3, 4, 5. And we have 5 edges. 1, 2, 3, 4, 5 in our final output. And we have successfully discarded the one that is causing a cycle. Okay. And total minimum weight. This is obviously taken care of because we have sorted them in ascending order and we are only including the weights in the ascending order if they are not forming a cycle. So as we go along, this is the minimum possible weights for building the minimum spanning tree. So that condition is also taken care. And we have discarded the edge that is forming a cycle. So this condition is also taken care. Okay. So this is the final output. This is our final output. So we will have these edges in our minimum spanning tree or the final graph that we have. Okay. So basically we have discarded one graph, this one. Okay. And as you can see, even if we don't include that graph, our graph is still connected and anybody can reach anybody using these connections. Okay, and we have kept our weights to minimum. This is especially useful if you're building complex networks like rail grids or electric circuits and things like that, right? So that is the concept of minimum spanning tree. Okay, so this is the theoretical understanding, guys, of the minimum spanning tree. In the next video, we will code all this and see how it looks like. Okay, so thank you so much for watching. If you have any questions, definitely ask me. Don't forget to leave a like if you found this helpful. Do comment if you have any questions or suggestions. Do subscribe to the channel. Do bookmark the playlist and share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.